Hey guys, today we're going to look at some actual real life situations of using similar triangles. Okay. So as we said, some situations are going to be more useful than others, and similar triangles are actually used all the time to figure out heights of things that we can't reach to measure. Okay. So here's the first example. A tree which has the height of 4 meters casts a shadow of 15 meters long on the ground. How high is another tree that casts a shadow which is 20 meters long? Okay, so the scenario is, the first thing is we have to draw a diagram. Okay, so here is a tree. Okay, so there's my tree. Okay, then this tree casts a shadow and we know the measurements. Okay, so this tree is 4 meters high, right? So it's pretty easy to measure a 4-meter tall tree. And it casts a shadow of 15 meters, right? 15 meters is easy to measure because it's on the ground, right? So the shadow is easy to measure. Now to complete this triangle, I'm just going to pull that hypotenuse, okay? Now we know a little bit of information about this triangle, and we know that the tree probably goes straight up, so we can probably call that a right angle. Okay, so there's the triangle that we're going to be working with. Okay, now there's another tree, okay, that casts a shadow of 20 meters. Okay, so here's my other tree. All right, it'll probably be bigger because the shadow is longer. There's my tree. Okay, now I need the shadow. Okay, and now I need to label that. Okay, so first tree shadow, second tree shadow. Now we know that this tree casts a shadow which is 20 meters long. Okay, and we don't know the height, and that's what we want to know. Okay, so also with this triangle, we should know that there's a right angle there. Okay, so right angle here, right angle there. Now it says include a similarity statement. Okay, so that means in order to even think about doing that, we're going to have to name these triangles, right? So let's name them X, Y, and Z. And let's name this one A, B, C. Okay? All right. So we've got one angle that we know. Okay, we've got a pair of sides that we know. We don't know another pair of sides. So since we don't know another pair of sides, we know that we're going to have to use angle-angle similarity. Okay, well, we've got one angle for sure, and the other angle is actually given. Okay, so I know that this angle is the same as this angle, because if the trees are close, then the angle of the sun is the same. Okay, so those two angles we actually know. Okay, so we can say triangle X, Y, Z is similar to triangle. And now since I went X, Y, Z, the order has to be the same. So A, B, C. Okay, and we're saying it's because it's angle-angle similarity. Okay, now I just have to show what the two angles are. Right, so angle XYZ is equal to angle ABC. Okay, and the reason is that we know that they're right angles. Okay, and we also know XZY, so XZY is equal to ACB, right? So Z is C, so ACB. And that information is given in the problem. Okay, all right, so we've given the similarity statement. Okay, so check. Now all we have to do is do the math. Okay, so since these two are similar, therefore we can say that the ratios of the sides are the same. So we can say that x over 4 is equal to 20 over 15. Okay. All right. And now we just cross multiply. All right. So x is 4 times 20, 80 over 15. and we can simplify that by saying that it's 5 and 1/3 meters. Okay? So that's the height of the other tree. Okay, so this tree is 5 and 1/3 meters. This one's 4 meters. Okay? Alright, so see how that works? We set up the similarity statement and then we did the math. Okay? So here's another example. So think about if you want to build a bridge across a river, right? To cross the river, it's probably not that easy because you don't have a bridge yet. Okay, so Jordan wants to measure the width of a river that he can't cross. He makes out the following measurements. Help him by doing the math to figure out what the width of the river is and include a similarity statement. Okay, so the first thing is it says include a similarity statement, so we're going to have to label these triangles. So X, Y, Z, and I'll call this U and W. Okay, all right, so we need to know some things. Sorry, I forgot to label that this is parallel to that. Okay? All right. So we know these two parallel sides. We know only one side ratio, 6:10. We don't know the other side ratio, so we can't use side angle side. So that means we're going to have to use angle angle. Okay? So the one thing you should automatically realize is that you have parallel sides. Okay, so once you have parallel sides, we've got some sort of pattern happening. And in this case, we can see a Z pattern, which now tells us that this angle and this angle are the same, if you remember your grade 9 math. Right? In a Z pattern, those two angles are the same. Okay, so we can start writing. All right, so we can say that angle, so I'll call this angle XYZ is equal to angle ZUW. Okay, and I still need another angle. Well, the easiest one to see is that these two angles are opposite of each other, right? So there's an X pattern. So when angles are opposite, we can say that they're the same. So XZY is equal to UZW. So angle UZW. Okay, now the reason here is because they're opposite. Okay, and the reason here is because it's a Z pattern. Remember, Z pattern means that the angles are called alternating. Okay, so we've got a pair of alternating angles and a pair of opposite angles. Okay, so that gives us two pairs of angles, which now lets us say that there are, in fact, two similar triangles, and it'll be because of angle-angle similarity. Okay, we just have to list the triangles. Okay, now this is a little bit tricky. The angles have to match up, right? So let's say I start with Z. Okay, the corresponding angle in this triangle is also Z. Okay, then in this one, if I go to U next, so ZU, then the corresponding angle to U is going to be Y. So here it'll be Y. And then if I go to W next, the next angle here is going to be X. Okay? So there's my similarity statement with the reasoning and everything. So that means that we can set up our ratio and solve for the width of the river. Okay? So the width of the river is right there. I'm going to make it called a little x, and I'm going to ask you to figure out what that is. All right, so you finish that, and we'll see you next time.